Alrighty, let's get started. So back to the Mandelbrot set. Um, After last time, I found an algorithm uh, called found a much better method of just converting from HSV to RGB, um, which gives much nicer results than what I had previously, and it's also much shorter. I don't know if it's faster, but it's definitely shorter. And yeah, so you can now do HSV, rainbow, acid trip, whatever you want, colors. um, is pretty cool. Um, so I also last night I just wrote a quick plugin for this that so basically now when I compile this and it gives me um, warning like this, I have some key bindings to just jump immediately to that definition, like whatever line the warning's coming from or the error. And I can also use that with what was that? I do, I don't know, GL context with like ag, it's getting used all over the place. Jump to all those very easily, which is pretty cool. So yeah. I was just getting sick of having to do that and then like manually search and blah blah blah. So, um, last time I got started on trying to implement this. It's not really shown in here. Well, okay, it is partially here. So this use approximation, which um, well, yeah, I guess it doesn't really we can't really see what's going on with this approximation here, but basically what we were doing is where do we recalculate Zn? So um, when we go to use this approximation, we pre-compute um, all the Zn values near the center of the screen, and then we send those to the GPU so that the GPU can just sample from that array. And then what the GPU does is if I open the GPU, if I open the fragment shader, um, let's open it. Remember how to type. Um, if we're using the approximation in the fragment shader, we basically compute this like epsilon value. Um, but it basically didn't work out too well last time. So I think the reason for that was that, well, basically, where are we here? Basically, the article on Wikipedia that I was following that was just describing this, like, renamed some stuff from what it should have been called in the, by the person who wrote this sort of algorithm. Um, so I found that one. I found just his paper. It's not really a paper, it's just a 2 page, like a 1.5 page LaTeX document. Um, just write up on this algorithm, which I will probably just dump in the chat. Well, let's do this. So I'll just dump that in the chat, and then also try to remember to link it in the YouTube video, which may get uploaded at some point. YouTube apparently cannot process 4K 60 FPS video in less than 48 hours, despite the fact that I'm, recording it in real time and encoding it using a more expensive encoding than what they use on YouTube. But yeah, apparently Google's unable to, just process a video in less than 48 hours. So we'll see how that goes. Um, yeah, so anyways, if we go back to this paper, um, basically what we can find in this paper is that this thing that Wikipedia was just calling, let's close that. The Wikipedia was just calling epsilon and not actually explaining what epsilon was anywhere. Is supposed to be the difference between 1 point Zn, so let's call it our center point Zn, or basically our Zn in this case is Zn of 0. Um, well, yeah, so, well, okay, it's not Zn of 0. It's Zn of I. It's the difference between this point and some other point um, on the screen, yn, let's call it. So we have yn, which is some other point on the screen. Basically, this epsilon was actually a delta, and that delta was delta n, obviously, was equal to some other point on the screen, yn, minus the xn or the zn point. So if let's see here. So basically, this yn is what we actually care about on the screen. We don't care about this epsilon. So this yn is like the other points that we're trying to approximate. And then this yn obviously just obeys the same Mandelbrot equation. Which, so basically what we can do is we can say, okay, let's say that the first delta n, so let's rename this because I don't like the epsilon name, it wasn't very clear. So this first delta n is just 0. And if that's the case, then we can use an equation for delta n, let's call it delta n plus 1, which was equal to 2 Zn delta n. Put some things here so it's visible. Plus delta n squared plus delta 0. Now, delta 0 is actually this. So we kind of need to, well, yeah, so never mind. Delta 0 is just this. So delta 0 is just going to be 0. So we don't need to do that at all. We can just ignore that part. Well, in this paper that I posted, actually they say that, okay, let just normal delta be equal to delta 0, like lowercase delta. We know all the values xn, this delta. Oh, I see. So this delta what we might want to do instead I don't know why they've just said that. So basic the author basically does a Taylor expansion kind of thing. Using delta n like delta zero, which is a little weird. Um because they do not define what delta zero is. It can't just be zero. I guess delta zero. Right. So delta zero cannot be zero. I don't know why Wikipedia just takes delta. It just says that. That doesn't really make any sense. You need to calculate delta zero. So you choose your point on the screen. You calculate delta zero, the difference, like the distance between the center point and your point. Um, and then, so really that needs to get moved into this little here. So vec to delta zero is equal to so well, I don't know why. Yeah. So time to rename some of this nonsense. Um, it might be a little nice to just have a function called uh, I learned that you can actually have out parameters and functions in GLSL, which is a little helpful. So let's have it return a vec to iterate iteration Mandelbrot iteration. I don't know. Well, it's okay. And it's gonna take a vec to z. Yeah, vec to z. Technically a vec to c, which we're not really using right now, but that's okay. And then it's gonna have a couple out parameters because we just need to know. It's gonna have an out float xx, and well, it could just be out vec to, well, probably more readable, out float xx, out float yy. So first of all, for delta zero, now I don't know like if well, then again it doesn't really matter. So yeah, we can still just use those. So we want to do a Mandelbrot iteration of delta, well, why are we even storing these two things as separate variables? It's a good question. Yeah, we don't want to do that. That's kind of pointless. So we need Mandelbrot iteration, VF Um, at a given iteration. Okay, sorry. So delta 0 is not, we don't, it's just VF minus the screen center, which like I don't think I passed that in as a parameter. I think we're just like using X. Well, no, never mind. It is just that point minus, yeah, Z and 0. So, where are we? U, Z, and 0. And then we have to copy, bring this on the screen. So we have XX equals, let's copy all of this, all of this out of here, possibly. I think the calculation is actually different, so probably I don't want this function. It's not very good. No function. Because the parameters are like different. It doesn't save me any typing because you have to do a different calculation for these two iterations. So like besides the squaring of x and y, but like, oh well. Um, so no more delta n out here. It doesn't need to be out there. Why was that? Oops. Okay. We're not using approximation. So where is what's complaining here? Deck 2 mult. D undeclared, E undeclared. Oh yeah, never mind. You need to delete those. Need to delete all of that nonsense. So this is delta n. Delta n is this equation we had before, which was this one. So it is 2 times Zni. I do wonder if we should skip the first iteration. I think we should. Zni times 2 times the old delta n plus how to line this up, plus delta n squared and plus delta 0. Okay, and then with that, we've calculated this, and then from our equation, we know that z is equal to, we know that delta n is equal to the point we care about, yn, or in our case, zn. No, it's the point we care about. Yeah, the point we care about minus zn. So like that's where this equation came from. So this is where like this iteration is coming from. But so this zn is here. And then I believe it would just be yeah, it's just this this guy. So plus delta n here. Okay, so D undeclared. Where is D shown up? D, for some reason we insist on using D, which is VF. D undeclared. Where is D? D is down here still. So many for namings. What did I do that for? Okay. So that is that. No more spamming of that. So if we go back to main now, and we go to UA, so we can, I don't need to rebuild it, and then we can close it and respawn it, and we can zoom in. I probably want to use the other one, but we're looking for is when we cross. So down here, we're looking for approximation equals 1. And I want to see if that is visible on the screen. Yeah, obviously it's visible because there's a bug. So, fun. Let us let's switch to the other color because it's a bit less flashbang. But I can't do this. Okay. So yeah, it's a bit better. So now this could be because we're not like before when you were on access, there was like this issue. So if we zoom in, we stay on, let's just make sure I just stay on access the whole time. And then we zoom in. Okay, yeah. So yeah, there's like an issue with the actually the approximation like is working pretty good. Besides the fact that the position is wrong. So if we zoom in and find something else here, yeah, we find this, right? We can still zoom in. I think this is like quite a bit further than before, and it's like still looking like something reasonable, but yeah, so we need to fix that other issue with the see basically like what's like actually happening here? Is it like flipped? I think it's like flipped. That actually might just be a fragment shader issue. Like if we just this doesn't need to be initialized first of all. But let's just see it if this is right. No. Well. Yeah, okay. So warning delta n use initialized. Why is delta n? Oh, okay, it does need to be initialized, my bad. Okay. Back to 0. Okay, well, if that's the case, then so why is that getting flipped? Okay, so this is the this part doesn't matter actually. So we don't need to use I guess we do this calculation here. Never mind. Okay, whatever. So why is it getting like, it looks like it's just flipped. Like, is there an issue with the way that I just calculated the ZNs in the main? Um, right. I should have left it open because I need to see the equation. So let me see here. Not there. What do we got here? So we get our rect center. So like the rect center shouldn't be negative. So, but we can try that in the fragment shader actually. If it's like negative, then that's wrong. Now we're like completely like, oh right, because it should only be like, it would be like one of these it would be negative and the other one wouldn't be negative. So let's just make sure we're in a place that I can see first. So we do this, go up here where we can see the parent flipping going on. It's like, that doesn't really make sense either, but that didn't even change anything, huh? Oh, this is, oh yeah, this is the knot. Okay, sorry. So, where can I see? I can't see because the Y needs to be fixed. So this is approximation. So, we, I don't know why I disconnected from the chat, but oops. Huh. I'm not sure what about that. Which has decided that I'm not allowed to read the chat anymore, I guess. That's okay. Don't need to read the chat. So let's go back to this. I'm definitely yeah, it's a little weird because OBS says I'm still streaming, but apparently I'm not still streaming. Apparently my internet is just gone. No. Okay, I don't know why don't know what's going on there. I'm definitely still live. Well, I'm not allowed to look at Twitch. That's okay. Um, so let me try this, flipping the X value. So that is still like not quite. Yeah, because now it just looks to me like both of them are flipped. Or like the center's just like way off. Yeah, I don't know. Looks like the center's just like gone weird for some reason. Um, I wonder why that would be. Oh, looking at the approximation, that's why. Um, if I force use approximation to be is it like actually better? Is what I'm curious about. Where is the thing that I was looking at before? So here is this thing, and this is now false. Now that is true, I need to find this thing again. Honestly, it's like pretty much the same thing, and I think that's probably because I'm not using, I should be using double precision for the CPU calculation. So I'm gonna try that, but I'm still like a bit concerned about this being like off center or whatever. So it doesn't make too much sense. Like possibly I should just pass the center in as well, so I don't have to deal with weird nonsense like that. So if I pass in the center of the rectangle, then what? Then instead of doing this, unless this needs to be uh it can't be, because if you just multiply it, then you're gonna run into the issue. So I think the x is 0 and s and z and 0. So this should like have been correct, because zn 0 means no iteration, and there's no c value. So yeah, weird. Well, Let's try like the double vector thing to begin with. So it's just that doesn't really make a lot of sense because then this whole proposed algorithm wouldn't really work because if you just have to have this in double, then you have to cast it to float for any of the rest of this approximation to work. That wouldn't make any sense. Because this relies on that value having precision. Which is a little weird. Like basically the output would be a dvec2 then, which is not making a lot of sense. The one thing I'm curious about is if I can do this again. Okay, and well, let's just get rid of this one for now. And then if I do now I'm curious about doing this and doing this and doing this, and this takes a screen position, this and this. And this has to be double. And this. And this. Where else? Interesting. So the log thing can only take float. So this would have to be cast to float, which, well, okay. So actually, that might be okay if we're just adding these. So you don't have to square root this, I realized, like, just use your log rules, right? That doesn't need to be square rooted. And then, dvec2, dvec2, dvec2. Initializer of type dvec2 cannot be assigned to variable of vec2. So where would that be? We're not using this function right now. I mean, I guess it's possible. We're not using like complex. '98. These aren't being used right now, but I just want to see if this will work. operands arithmetic operators must be numeric. What does that even mean? Oh, no matching call to, yeah, right. Fine. I don't want to do this all in double. I just want to see if it actually works, though. That's all I'm curious about. It seems to. So if we're not using the approximation, we're just putting a false here. We don't use it. I should find somewhere better to zoom in on. Hello. Ooh, that starts to like, oh, that, oh, whoa, 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 we don't want to do that. Yeah, so the double is way, way, way slower than the float. I definitely dropped some frames by doing that. Oops. Oops. But this definitely would not have been visible. I need to stay away from the very slow dropping rendering frames section. This stuff would have not been visible with the yeah. So you could technically use the double. Let's just scroll that off screen for a second here. But it is significantly slower than the float. So I do not want to do that. I was just curious. There's like a few things I meant to clean up though, so let's just fix all of this. Now if we go back to our nice fast rendering with our, oops, that is broken approximation. Why is the approximation broken now? Oh, because we're like way off. Yeah, never mind. They're nice pixelated, not zooming in very far. So first of all, actually, I need to do this. This was stupid. I don't want to do this square root anymore. I want to do 0.5 times this, and I also don't want to do this divide by log 2 to get the logarithm in base 2 because there's a log 2 function. This won't change anything. I don't know why this one is base n versus base 2. I don't fully understand this normalizing the Mandelbrot escape, but yeah, so anyways, that does the same thing. So so still a little stumped about how to improve the accuracy for those we're approximating. I don't fully understand how this thing is like this author did this wasn't like completely random. Like this author had actually created a Mandelbrot thing that was working with this. That's why I'm like a little confused as to what the problem is. There is one thing though I did realize, which is give me a second. Yeah, sorry about that. So yeah, this author just like had published or not published, had created a program using this method supposedly, and it just worked. Um, I don't fully understand what the issue is. So they've got like a different this Taylor expansion part, which theoretically is probably just faster to calculate, to be honest, or I guess no, I see. This Taylor expansion part's like the part that actually matters, I think. This Taylor expansion part is the part that makes it arbitrary, like that gets rid of the precision issue because you can get rid of the squared. You can get rid of the squared term. You only have to square right. You only have to square like delta zero. So let's try that part. Basically what the author is saying is that you can do delta n expanded in a Taylor series is equal to some coefficient an times d. Let's call it d, but let's just put this up here. So d equals delta 0 plus bn times d squared plus cn uh, times d cubed um, plus some term, some function of the fourth order terms, but we're just dropping those. And then if that's the case, then an can be calculated using 2x 2zn 2zn uh, an plus 1. I'm not even sure why they've listed these other parts here, to be honest. Oh, sorry, they listed this other part to show how this Taylor expansion comes. Yeah, okay, right. So it's an plus 1. What happened here? An plus 1 is equal to 2zn times an plus 1, literally a plus 1. And then bn plus 1 is equal to 2 times zn times bn plus an squared. And then cn plus 1 n plus 1 is equal to 2 times zn times cn plus 2an 2 times an times bn. And then using this, you can calculate all these delta n terms. without doing any like squaring, which besides the first term, which I feel like should still be an issue, but maybe it's not. I guess it like depends on how the Mandelbrot set like actually behaves. So because it's just recursive, um, right? Because it's just recursive and you're just like squaring a term over and over again, it's gonna quickly need like very high precision. But in this case, we're not doing any of that, and this ZN's already pre-computed, and it possibly needs to be higher precision, but I'm not sure about that. Um, so let's try this one. We have our delta 0. Um, so we'll pre-compute these values. We'll pre-compute those values, and then now what are these? Are these constants? Yeah, these constants are also complex numbers. So okay, this is like some weird. Yeah, so okay. This is like some weird cryptic. The way this thing is written is a little weird. So um an a1, sorry, a1 sorry, in our little equation here. So okay, so we need a0 first. A0 is equal to that even right? A0 has to be equal to okay, yeah, a0 is equal to 1, sorry, 1 0. That's what I was thinking of. Yeah. A0 is 1 0, and then a1 is 2 times xn plus 1. And then b0, no, b0 is 0. b0 equals 0, b1 equals 1 0, and then I think we need to do the 2's as well, the second term, because that's where we get this first. Yeah. So, and then a2 is equal to 4 times x1 times, this isn't xn by the way, it's x0. 4 times x, so these are both z, my bad. Let's use the right notation here. times z0 minus 2 times z1 minus 1, and then b2 is z0 minus 1 squared, and then c0 equals 0, c1 equals 0, c2 is equal to 4. I don't know what that noise is, to be honest with you. Also still like very confused about why I can't load Twitch, but I can you know, just yeah, I don't know why I can load Twitch, but I can't, or why I can't load Twitch, but why I'm streaming just fine. So, is there anyone in the chat? I'm sorry, can't read your messages. Cannot do it unless I open another computer. And then okay, so yeah, so Cn or C2 is going to be equal to 4 times z0 minus 2, and that's it. So from here we can do this recursive step because now we've got like all of these terms. And does this just follow from this? Does this recursive step here follow these? An plus 1 should be equal to 2 times zn times an, which is just this 1. So if it's 0, right? So we want to find when n is 0. So this should be 2 times zn times 1 plus 1. Right. So yeah, that follows, which is good. I'm not going to expand this, but just assume that was correct. And then same for b. So we want to find b1. So n is 0. The 2 is at n. B of 0 is 0. That goes away. And a of 0 is just 1. So that makes sense. Yeah, I think this seems to be making sense to me. And then yeah, so that would all make sense. Do we actually need these like pre-computed values? I don't think so. I don't know why they're like written here. I think we just need like the first ones, right? Like C0, B0, A0. So we have delta 0. We just need like the initial value. I'm not mistaken here. So got our delta or D or our delta 0. So we should just call this vec2 D is equal to delta 0 vec2 A. So A at 0 starts out as vec2 1 0, and B at 0 starts out as a 0 0, and so does C. And then What's the syntax error? Where did I introduce a syntax error? Hello? Like, maybe it's just you're not allowed to do this if they're both 0. No, it's still there. Oh, I'm missing a semicolon. Good. Good. Semicolon missed. Skill issue. Okay, so we've got those. So then, and we've got our initial value. I think so. We need delta n, but delta n is not going to be equal to this thing anymore. Delta n is going to be equal to A. So complex mult A times B plus complex mult B times dB plus complex mult C times dBd. Okay, and then so that is looking good, and then that is good, and then let me think here. This is fine, and then we need to iterate A. A is equal to 2 times, actually, it's down here first. Oops, the link. How the link got copied again. I also forget how to type. So then A, where are we here? A is equal to 2 complex mult. I think when they say +1, they mean +1, like +1 in the real and +0 in the complex. So 2 times this one. And A plus vec2 1 0, and then B is 2 times Zn times B plus complex mult this is a bit annoying. I need to like save these values. I should do it like in reverse. Okay, and then C is equal to complex mult. Now, I don't know how much optimization the shader does. It does look like we're just doing this thing over and over again, but it may or may not be okay. I think just I'm gonna shove this in here as well. 2 times A B. Okay, do that for now. Yeah, so that should all be correct. Those iterations. And then, yeah, the use approximation. This is the new use approximation. And it compiles fine, apparently. And we're in using false, so, well, this may have the same issue still with like weird off center stuff, but you zoom in. Yeah. So let's try zooming in somewhere here. So no, there's still like an error here. Did I do something? Did I miss a step here? Like, does this even work if uh well, in some sense that's a Mandelbrot. It's kind of cool looking. Like making like a streaming thing. Oh, bye bye. Bye bye Mandelbrot. I think that's because I reset the Z ends. It's only getting like calculated. It only gets calculated when you zoom in like far enough, so I mean I could do that. Oops. Wait, that doesn't make sense though. It like got calculated and then this goes like way off to nowhere land. That's funny. Um it's funny but probably not correct. Why is there like a part of a circle here? Weird. Weird. I'm still not allowed to watch my own stream on Twitch, so funny. Okay. Um, so I might need to actually fix the C code now, or something is wrong with this calculation. I mean, it's possible. This like map Mandelbrot thing is a little sketchy. This multiplication. Um, yeah, because how will the shader just know it needs to we need to calculate its position in the actual screen coordinates that are being used. So how will it just work? We're not even like anywhere near. That's funny. Hmm. Okay. Yeah. So this is what we want to do. We want this to work. So how can we get this one to work? So this oh, excuse me. This calculation should all be correct according to that paper. So for this approximation, so the delta term this equation is used to calculate the nth iteration. So yeah, so we're calculating the next, these are the next values. Next values. And including this, right? This is actually, no, this is actually the, yeah, this is the current delta n. I think this is correct, honestly. I think this part of the code is correct. According to the paper. The paper, it's not really paper, but so the minimum n required to give Mandelbrot n more than 2. Yeah. Equation 1 is important. All numbers are small, allowing it to be calculated with hardware flim. Okay, so yeah, so if we know all the values x and we use this, so this approximation is, this part of the approximation is correct, but I think it's like this point. How can I just get this point without running into issues? So this point here, this VF is from 0 to 1. Sorry, this part is from 0 to 1. Then it gets passed in here and gets multiplied by this scale, which is small. Possibly we can do, you just see here. So if this V, let's do it this way. Let's calculate this. But if we do the scale first, and then the division. I don't think it works because the scale's just going to shrink it, and then the division's going to shrink it even more. Oops. Okay. So, if I can try it, I guess. in this case, we're gonna delete this, and we're gonna go up here. We're gonna do v equals v times scale, and then v divided by this. Didn't change anything really, but isn't this not... Are we already using the... No. Why does that look different than before? Don't know. Do not know. It's okay. It's okay, we'll just go back to Uzumaki land. This isn't even like the worst part of that. So so yn, at this point, we're assuming it's like this is fine. So as long as this calculation here, this VF is this VF isn't compressed to 0, basically, then this is correct for figuring out that delta 0. Because, yeah. Is this center point just like running out of precision? That's what I'm like curious about in the C file. Let me see. So let us do recalculate Mandelbrot. And I don't want to... Let's make a new type just for now. A double vector 2. And then here we will steal a double vector 2 of memory. It's just the problem is that if I just do this, there's going to be a problem, but... Yeah, let's not do this yet. Yeah, let's not do that. Let us... This rectangle center, I'm just like really worried that it's gonna be like basically 0 from the floating point perspective. So like right here, it's not like quite 0, but It's a problem. That is a problem. How can I do that? Yeah, I wish I could like examine what the values were on the GPU. I don't know. It's a bit difficult to do that. Um, so we want the center of the screen be that value. And then well, one problem, and actually this is probably why that other part was misaligned. If I go to the fragment shader, and is that uh, yeah, so in the case where we're using the approximation, we want points um, around the center, not how this is right now. We need the center to be uh, we need each corner of the screen to be like this is like minus one, like minus one x plus one y, plus one, uh, plus one x minus one y, and then minus one. We need those corners for this calculation. So probably we want to switch this up a little bit here. So if we use yeah, so this thing probably I can't do this in here anymore for now. So this will still work if I did this. So um uh normal chords equals this if you use approximation. Um, let's just do it this way. Does VF need to be like existing outside of? Never mind. Let's not do it that way. If you use approximation, uh, vec2 VF. VF equals map Mandelbrot 2 times normal chords minus 1. Else what happened here? So not construct vec2 from non-numeric data type. Normal chords. Normal. Where is the problem here? I delete something I wasn't supposed to delete. Oh yeah, I deleted the Z. Um That's better. So that part looks fine, and then when we zoom in though, we still have like the this problem. Which is what problem? Uh, what is happening? Well, I don't know. I'm pretty tired for tonight, so I think I'm gonna call it there. Um, yeah, it's a little annoying that we didn't figure that out just yet. Um, this is like partially fixed, but also not partially fixed, so we will go back to this one for now. And we will have some rainbow, some trippy rainbow people acid trip, people acid. Have some people acid to end the stream. Um, yeah, thanks everyone for watching. I have no idea if there was anything in the chat. Because for some reason I'm not allowed to connect to Twitch right now, despite the fact that I'm not dropping any frames. So, yeah, cool. See everyone next time.